and good day, pre-algebra. We are going over CO41 today, which is determining if two ratios form a proportion. And before we get to, there are 5 different ways, all of them key points, which means all of them go on a help sheet, but 5 different ways to determine if two ratios or rates are proportional. What's a proportion? Let's define that first. What are we really determining here? If two ratios or rates are proportional, what does that mean, Aiden?
It means like that one's like sort of bigger than the other one.
Okay, so if you think about, like if we look at this first one here, 3 to 4 equals 9 to 12. 9 and 12 are bigger numbers. Is that kind of what you're saying? Okay. We'll come back to that a little bit. Yeah. They're equal. Their values are equivalent. Even though the numbers are bigger, 9 and 12 are bigger than 3 and 4. Notice that symbol in between 3 to 4 and 9 to 12, that equal sign. Their values are equivalent, which kind of leads us to our definitions. Values that are proportional are essentially at their core equivalent fractions. Okay? Ratios or rates that are proportional are essentially equivalent fractions, such as 3/4 and 9/12. Okay? And we're going to go over 5 ways that we can determine whether or not these rates are at their core equivalent fractions. This isn't going to work for me today. I would like you to move over there. Okay? Thank you. So the first way, how we can determine or prove that 3/4 is equal to 9/12. How can you verify for me that 3/4 is equal to 9/12? What would you do to prove it? Aiden?
3 goes to the 9 3 times.
Yeah, scale a factor, right? If we multiply both 4 and 3 by the same thing, we get to 12 and 9. So scale factor by multiplication. Okay? Scale factor by multiplication. If we can multiply both our numerator and denominator by the same thing, in this case 3, we get to 9/12. Which you can see I've got the same fractions in our second one because it works the other way too. If we start with 9 and divide by 3, or start with 12 and divide by 3, we get down to 3 and 4. So scale factor, by division is method number 2. If you can divide both your numerator and denominator by the same thing, then they are proportional. They're equivalent fractions. This isn't really news to you so far, right? You've talked about these before. You've worked with equivalent fractions before. We've talked about scale factors before. So it isn't exactly new information, but all 5 of these are all going to be on one page for you. All key points. They're all kind of together. These are the 5. Right? Are we good with the notes? Can I scroll on down? Okay. So what if you've got, too far. What if you've got 2 fractions that you can't really get from one to the other using a scale factor, like 3/6 and 4/8? What do we multiply 3 by to get 4? What do we multiply 6 by to get 8? Right? So if the scale factor isn't really a good method to use, what's another way? What's a way that we could prove that these 2 fractions are equivalent? Aiden?
Fraction of 3/4, and then you can see that that's equal to 6/8.
Are you kind of saying you compare the numerators? What do you mean 3/4 and 6/8? Are you saying like go across like this?
Yeah.
You know what? I've never had anybody say that before. I'm trying to think if that would actually work. In my head, I'm trying to run through. That is kind of brilliant. I'm not going to put it down because it's not one of my 5 that I want you to know, but I like it, actually. So going off of that, though, even if we had 3/4 and 6/8, scale factor still wouldn't be applicable there. So my main point, that's really nice, Aiden. I like that a lot. My main point doesn't or still applies there. What could we do? Yes, Yvonne? Simplify, right? We know that 3/6, so we can figure out, put it in simplest form. 3/6 is equal to 1/2. If we simplify 4/8, that is also equal to 1/2. Okay, so if you simplify both fractions and they equal the same thing in simplest form, in this case 1/2, then you know that they are equivalent. Okay, simplify both fractions. Simplify both fractions. 3/6 and 4/8 both simplify to be 1/2. Okay. Another method. Anyone know another method you can use to compare fractions and ensure they are equivalent to? Have you heard of cross products before? What are cross products? What is cross products? Annika. The 114 and the 25? Yeah. So cross products, I'll fill it in here first. Okay. If you take the product of the numerator of one and the denominator of the other, so 15 times 190, and then the product of the denominator of the first and the numerator of the other, 25 times 114. If the fractions are equivalent, those two products will be the same thing. So 15 times 190, quick maths, is 2,850. 25 times 114 is also 2,850. Because those two products are the same, we know the fractions are equivalent. And cross products works really well when you've got fractions such as this, where they're a little bit larger. You might not be very familiar with how to simplify 114 over 190. You're not sure the scale factor might be there. You know that 25 won't go into 190. Okay, cross products is a nice quick method that you could use. The last method is to compare the decimal values. And actually, of all of these that I can't do mentally with scale factor or simplifying, I like this one the best. Because all I do is I take out my calculator and I say, all right, calculator, tell me what 8 divided by 7 is. Because remember, a fraction is just division. So is a rate. Okay? 8 divided by 7, and I'm rounding here, is approximately 1.14. Okay, calculator, what is 28 divided by 24.5? Well, 28 divided by 24.5 is the exact same decimal that I got for 8 divided by 7, 1.14. Because those decimals are the same, these fractions are equivalent. Okay? So the ones you can do mentally, the scale factor ones and the simplifying ones are really great. But we're going to get into some fractions and some work that is kind of beyond just the mental math, the small numbers that you worked with from K to 6. So these two here, the cross products and the comparing the decimal values, are ones that you're going to be using more and more often. Annika. Proportion are essentially equivalent fractions or equivalent rates. Equivalent fractions, I think what I put up there. But if you want to add or rates to that, then that's fine. But equivalent fractions is the gist of it. Questions so far? Okay, so if you flip the page, you'll see you've got a bunch of fractions listed there. And the difference is, notice how on this page, I've got the equal sign. I'm telling you those fractions are equal. On the second page, I don't. On the second page, I'm just giving you 4/5 and 20/25. I'm not telling you whether they are equivalent fractions or not. You need to prove it. You need to decide. And you need to do so using 2 of the methods discussed on the front side, 2 of the 5. Why 2? Because it's more practice. And also, if you use one method and you say, oh yeah, they're equivalent, but then you use a second method and you say, wait, they're not equivalent. Your 2 answers should match, right? Using 2 different methods shouldn't give you 2 different results. So it's a way to kind of check your work and make sure that you're doing it correctly, because if they turn up equivalent using one way, they have to turn up equivalent using another way, or you did something wrong. Aiden.
Could a method count as the one I said on the front side?
Let's steer away from that for now. I'm in the few examples I did in my head. It worked, but I got to test that theory a little bit. So do the 5 that we talked about, and we'll come back to that later on. Okay. So let's pick one of these first 6 that you'd like to do together here. Which one looks particularly worthwhile as doing together? And we do need to show our work here for credit on this assignment. It does say to show your work. So we'll do that together. I'll show you what I mean. Maggie, what would you like to do? First one, bottom row. Okay. So 18/28 and 81 1/26. Let's kind of run through what's going to be easiest for us to use here. Is there a clear scale factor between 18 and 81? Does 18 go into 81 evenly? No. And we know it doesn't because 18 is even. No even number will ever go into an odd one. Okay? So scale factors out. Simplifying. Well, 81 and 126 are kind of larger numbers there. You might not quite know what to divide by. So that might not be the best method. Let's use cross products. So for cross products, I'm going to put a little 1 here because this is method number 1. Cross products tells me I'm going to multiply the numerator of 1 by the denominator of the other, so 18 times 126. And I'm going to multiply the denominator of the first by the numerator of the second, 28 times 81. So quick maths tells me that 18 times 126 is 2,268. 28 times 81 is 2,268. Are these equivalent rates and equivalent fractions? Yes, because cross products tells me so. Those products are the same. Okay, so I already know they are, but I'm going to verify it. I'm going to double check it by using a second method and thus getting ultimately more practice. Based on the fractions that we have, we already said scale factor probably wouldn't work out too well. Simplifying the fractions, larger numbers here. Let's go with comparing decimal values. Okay, so to compare the decimal values, I'm just taking each fraction and dividing. 18 divided by 28 is a long, nasty decimal, but it's approximately 0.64. 81 divided by 126 is the same long, nasty decimal that I got for 18 divided by 28, approximately 0.64. So yes, these are equal. I've proven it using 2 different methods. They are equivalent. Okay? I feel like going back to Aiden's point, I feel like, Aiden, if you had used your idea there and you kind of looked at them horizontally and you looked at 18 81sts versus 28 126ths, I feel like you'd still end up needing to use one of these methods here you know, because if you rewrote the fractions horizontally like you suggested, you know, how are you going to tell me that those are equivalent? You still need to use one of the methods on the first side. So it's almost, I'd say, more efficient to go straight there with the fractions given rather than rewriting them, okay, and then using one of the methods, okay? All right, another one you'd like to do together. Annika, the last one, 16 70-seconds over 92 3/78. Okay, well, does 16 go into 92 evenly? Anyone know? So maybe we shouldn't use scale factor, huh? Anyone want to try and simplify 92 over 3/78? No, me neither. Okay, so let's use, again, cross products. 16 times 378 equals 6,048. And then 72 times 92 is 6,624. Are those equivalent fractions or equivalent rates? No. Because those products are not the same, that means they're not going to be equivalent. But let's verify it by using a second method in case we made a mistake, pushed the wrong button on the calculator or whatever. So comparing decimal values here, method number 2, we're going to divide the fractions as they are vertically. 16 divided by 72 is 0.2 repeating. Just round that to 0.22. And 92 divided by 378 is 0.24 when rounded to the nearest hundredth. Those are not equivalent decimals. Therefore, these rates, these fractions, are not equal. Okay? So I don't care which two methods you decide to use. You can use the same two methods for every single one. If there's one you can do mentally, like I presume this 4/5 and 20/25, you're probably going to use scale factor for that one, or simplified 20/25. So those are pretty common fractions, smaller numbers to use. But as you get to the larger numbers here, or you just want to be consistent, cross products and comparing decimal values will work for all of them. But I do need to see the work shown, and that's an example of it. Okay. Pause on this for a second because I do want to go down to the next section here. Not all the way down to PO42 though. So here's where we get to actually apply this stuff. Okay, a juice recipe requires 5 cups of orange juice for every 2 cups of water. To make the recipe for a group at summer camp, the counselor mixes 45 cups of orange juice with 30 cups of water. Will the juice taste the same as the original recipe? If not, what will be different? Okay, so here's where we're comparing 2 recipes to see if they are proportional, to see if they're equivalent. We've talked about baking before, right? If you're making, a gravy boat for your whole family at Thanksgiving, you're probably going to need to double or triple the recipe as it's provided to you. You're making it for more people. So we've got this original rate of 5 cups of orange juice, 5 cups juice for every 2 cups water. And that's the rate that you apply juice to water. If you want to double the recipe, you'll have to double the juice and double the water. Right? If you only double the juice and not the water, it's going to taste more juicy, right? If you only double the water and not the juice, it's going to be more watery. So you want to keep it in proportion. And we want to see if this is proportional to the new recipe, or what the counselor actually made, which is 45 cups juice and 30 cups water. Are those two recipes proportional or not? I see some people shaking their head no. Why not? Leah? Yeah, using scale factor, we can pretty easily see, okay, we multiplied the cups of juice by 9. Okay, so using scale factor, we multiplied the cups of juice by 9 to get 45, but if we multiply the cups of water by the same thing, we get 18 instead of 30. So it's not going to taste the same as the original recipe. What's going to be different? Is it going to taste more juicy or more watery? Maggie? More watery, right? Because we have more cups of water than we quote unquote should. And it's a summer camp, they're on a budget. Water's cheaper than juice, so of course if they got to make more, you're going to water it down a little bit, okay? That's how you're kind of approaching these. This second one, Target sells bananas in bunches of 8 for $4.16 and 12 for $5.88. Which one has the better price per banana and by how much? So you're given two different rates here. 8 for $4.16 and 12 for $5.88. I want to highlight this phrase though, price per banana. What concept that we've learned previously are you going to be using to answer this question? Aiden? Unit rate. Price for one banana. And I'm going to give you a hint on how to set these up. You want to write these rates as $4.16 for 8 bananas and $5.88 for 12 bananas. When you have the phrase price per banana, it means you want to have your price as your numerator and the banana as the denominator. Okay, so you're finding the unit rate for each of those to see which has the better price per banana. Mrs. Schultz can do 63 parent conferences in 4 hours and 12 minutes. Mr. Blackhawk, I forgot to change this. He's a teacher, Eddie Epiphany, can do 48 parent conferences in 3 hours. Are the rates at which these two exceptional gentlemen conference proportional? If not, who averages the quicker conference and by how much time? So this question kind of goes back to this top one here, and actually unit rate as well. You're comparing our two time rates per conference, and which one averages more quicker conference and by how much time. So, questions on what you are to do in CO41. Determining whether things are proportional and then applying that knowledge into context here on the bottom section. This is homework that's going to be due on Monday because tomorrow is a retake day, so you have the weekend to do it plus an extra day on Friday. So no excuses for no number game on Monday. Let's start try 3 off with a bang, shall we? Yes. Questions, comments, concerns, complaints, comments, congratulations, or criticisms on PO41? All right. With gusto, that's how you math.